Are we truly alone in the universe? Or is there intelligent life out there waiting to be discovered? Join us on a journey to uncover the secrets of the cosmos in our groundbreaking video. The search for extraterrestrial life. What we know so far. Buckle up and get ready for a mind-blowing exploration of the final frontier with exclusive insights and cutting-edge research that will leave you wondering if we're not alone after all. Don't miss out on this epic adventure and watch the video now. What is extraterrestrial life? Extraterrestrial life, colloquially referred to as alien life, is a life that may occur outside of Earth and which did not originate on Earth. No extraterrestrial life has yet been conclusively detected, although efforts are underway. Such life might range from simple forms like prokaryotes to intelligent beings, possibly bringing forth civilizations that might be far more advanced than humankind. The Drake equation speculates about the existence of sapient life elsewhere in the universe. The science of extraterrestrial life is known as astrobiology. Speculation about the possibility of inhabited worlds outside the planet Earth dates back to antiquity. How do scientists search for extraterrestrial life? While the question of whether life exists beyond Earth is still unanswered, scientists have developed various methods to search for signs of life beyond our planet. One of the most important techniques involves searching for biosignatures, which are chemical or physical markers that indicate the presence of life. These biosignatures can include things like oxygen, methane, or other complex organic molecules that are produced by living organisms. Scientists also look for conditions that are similar to those on Earth, such as the presence of liquid water or a stable atmosphere, as these factors increase the likelihood of finding life. Additionally, scientists have deployed a range of technologies to detect potential signals from extraterrestrial civilizations, such as radio telescopes that listen for communications from other planets or advanced telescopes that can detect signs of life on exoplanets. Ultimately, the search for extraterrestrial life is a complex and challenging endeavor that requires a multidisciplinary approach and a combination of cutting-edge technology and scientific expertise. However, with every discovery and advancement, we get one step closer to answering the age-old question of whether we are alone in the universe. Where are we on the search and what do we know? Relatively soon, some prominent astrobiologists say we will most likely have either found compelling evidence for extraterrestrial life or banished its possible existence to the ever-shrinking edges of the cosmos beyond the rapidly expanding reach of our observations. Such answers could come by the end of the 2030s from any of several initiatives ardently seeking alien life. By then, samples from Mars will have arrived back on Earth, perhaps containing concrete proof that the red planet once harbored organisms or still does today. Spacecraft at Jupiter's Europa and Saturn's Titan will be scouring both moons for signs of life residing in each world's subsurface ocean or, in the case of Titan, on the surface itself. And advanced telescopes on the ground and in space should be probing the atmospheres of potentially habitable exoplanets around nearby stars, looking for any that share the same biology-infused cocktail of gases as our own living Earth. As confident as astrobiologists may be that their quest will soon bear fruit, however, they are far less certain of how to communicate that success if and when it occurs. How should they go about informing the world that we are truly not alone in this universe, especially given their field's long, troubled history of dubious claims and false alarms? They have been fooled before, after all. Then communicate the detection of biosignatures beyond Earth, like the Torino scale for assessing the danger of asteroids. Their idea is to use a scale from level 1 to level 7 that will allow confidence in any given case to be gradually increased. Known as the confidence of life detection, or COLD scale, it calls initially for simple confirmation that a result is not linked to contamination or some abiotic origin, whereas its final levels would represent robust follow-up observations solidifying a link to live. These things are complex, Green says, but we need to be able to communicate it simply. Recent discovery. The search for extraterrestrial life is an ongoing effort that involves the collaboration of scientists and researchers from around the world. While we have not yet discovered concrete evidence of life beyond Earth, there have been several promising developments in recent years that suggest we are getting closer to this goal. One of the most significant recent discoveries has been the identification of thousands of exoplanets, planets that orbit stars other than our own, many of which are located within the habitable zones of their respective stars. This means that they are at a distance from their star where liquid water could potentially exist, which is a key ingredient for life as we know it. Additionally, the discovery of complex organic molecules on other planets and moons in our solar systems, such as Mars and Europa, suggests that the building blocks of life may be present elsewhere in the universe. Moreover, the ongoing efforts to develop advanced technologies to detect biosignatures and signals from extraterrestrial civilizations hold great promise for the future of the search for extraterrestrial life. However, given the vastness of the universe and the challenges inherent in detecting and identifying signs of life, it is impossible to predict when or how we will ultimately make contact with life beyond Earth. Nonetheless, the search for extraterrestrial life remains a fascinating and important pursuit that has the potential to revolutionize our understanding of the universe and our place within it. Martian extraterrestrial life. Evidence for life on Mars has been claimed for more than a century. The first such argument was posed by a French astronomer, Etienne L. Trouvelot, in 1884. The seasonal changes on Mars have been reliably observed, not only visually but also photometrically. There is a conspicuous springtime increase in the contrast between the bright and dark areas of Mars. Color changes with the season have also been reported. Space probes have found no vegetation on Mars, but seasonally variable dust storms provide a convincing explanation of the color changes. Historically, life on Mars was argued for based on the canals. This apparent set of thin straight lines across the Martian bright areas extends for hundreds, even thousands of kilometers and changes seasonally. First systematically observed in 1887 by Italian astronomer Giovanni V. Schiaparelli, the lines were further catalogued and popularized about the turn of the 20th century by American astronomer Percival Lowell. From the unerring straightness of the lines, Lowell argued they could not be natural in origin. Instead, he interpreted them as artificial constructs built by intelligent Martians. As we continue our search for extraterrestrial life, we are reminded of our place in the universe and the endless possibilities that lie ahead. The quest to find life beyond our planet is not just a scientific endeavor, but a human one driven by our insatiable curiosity and desire to understand our place in the cosmos. With each discovery and technological advancement, we inch closer to unlocking the mysteries of the universe and uncovering the truth about our place in it. So let us keep searching, keep exploring, and keep dreaming of the day when we finally make contact with our cosmic neighbors and take one giant leap forward in our understanding of the universe. If you found this video helpful, kindly subscribe to our channel so you won't miss out on our videos.